people to come and for just warm the presentation of Shelley, just talk. Welcome, everyone. We are starting the 8th workshop on data science from Escola Politécnica of University of São Paulo. Everyone is so much very welcome. This is so nice to have you guys in this presentation. We are going to start 3 keynotes during this afternoon. We have Shelley Stall, first presentation. After we have Mohammed from DataSite and Gir Prakash from ARM in Oak Ridge National Laboratory. So I'm talking about a little bit about this workshop, what you are doing here, and the importance of this workshop. The workshop that we promote usually every 2 years. Three years ago, we promoted the workshop of a Parsec project. Last year, we promoted a workshop about the software that we developed here in Brazil, data map that useful for published data from Amazon. And this year, this workshop, the focus of this workshop is to training the researchers from Amazon Face. So this is just general view. The Amazon Face is a study that try to understand the effect of CO2 on tropical forest. And we are developing new data models for open, interoperable, reproducible practices using collaborative science and climate resilience. During this afternoon, we have nice keywords, keynotes to talking about in general about open science, talking about the data management, talking about the best practices for open science and data management, data management, scientific data management. So today, I think we'll have a very productive time, and our idea is to disseminate these best practices for scientific community and the data scientists interested in data management in general. So we can start right now. The first keynote, Shelley Stall. Shelley Stall is Vice President for Open Science Leadership at American Geophysical Union. AGU is a very large institution in US, but it has influence in all world. AGU. I think Shelley Stall will talk about a little bit about the AGU. I think is very important for everyone, every researchers that are interested in this kind of atmospheric data, and it's very important people knows better about AGU. Shelley Stall, thank you so much to attend as a keynote of our workshop. Please feel free to start anytime when you are ready to start. Thank you.
Thank you, Professor Carrera. That is, it is my absolute delight to be here. I'll talk a little bit about AGU just in case any of you are unfamiliar. I'm going to share my entire screen. Bear with me as I navigate Google Meet. Share. I think it's happening. Great. All right. So this is a slide that describes the American Geophysical Union. We have been in existence for over 100 years. And you know, when you're in Europe and you say that, they giggle. They're like, yeah, that's not that long for us. But for the US, it's quite a long time. And we hope to be here for another 100. Our community is quite vast, and we include all of the earth, space, and environmental science researchers, especially, the folks that are working now on Amazon Face, very exciting. You're part of our community, and we're delighted to have you. This year is a little strange for us because of our challenging reduced funding for science within the US because of our geopolitical challenges. But those things come and go, and I imagine that will get rectified soon, or at least mitigated. And so there's quite a lot of folks. So we're neither American any longer, and it's not just the geophysics. We include all the planetary and space and oceans and all of that. And so our branding of AGU we're left with, but we've expanded quite a lot. So I certainly invite you to attend one of our upcoming meetings. Our large meeting is in the middle of December, so it's coming up. This year it'll be in New Orleans. And for students, there's opportunity to actually get a travel grant. Professor Carrera, I will make sure you have a link to that to share, especially for next year, for folks to potentially come and attend. So that would be fantastic. Let me switch over to the other slides I have for you. Here we go. So on the project for Parsec, which has completed but has spawned so many more partnerships and projects to work together, which is why I find myself continuing to be invited to Brazil. Thank you very much for that. It is such a delight. We built a lot of materials around what we call an open science journey. When you're working in research and you're working in science, you understand that you're learning new techniques and new capabilities every day. And research does not stand still. It continues to develop new methods and new approaches for all of the continually challenging areas to explore and understand. And that is also true for open science. Open science is science, and it recognizes the fact that we don't do research by ourselves. We are not alone. We are on teams, and those teams are commonly multidiscipline and multinational. And being prepared to work in that environment and take advantage of those connections is what this material is all about. So I'm very delighted to share this with you. Professor Carrera, as well as the large number of teammates on the Parsec team, Jeanette Macchiato, and I'm trying to think of some of our other Brazil, Solange Santos, Catarina, oh boy, Pedro, I didn't get our list together. So many amazing folks in Brazil that were, I consider the Brazil team the anchor team for the project. Yes, the absolute anchor team. We working with such passionate groups such as yourselves, supporting and understanding and learning, as well as the teammates that took the research forward, partnered with every other country on the team. I see Brazil as our anchor team. So that was really exciting. This material, the specific slides, were informed by all of those conversations and specifically developed by Allison and myself. Allison Specht, who's out of our Australian team. She was the lead PI, is the lead PI for the Parsec project. And so the two of us put these materials together. So I want to make sure I give her attribution for the work that we're doing here. So let's move on. This picture is a snail taken at the Intervalos State Park, just south of you all, where you're standing. It did not have an animal inside of it, so it was an empty shell, but it was very large, and it represents this open science journey. And as we came to understand a spiral, that spiral indication there at the point of the shell, as being representative of what it means to walk through an open science journey. So this is this picture we try to use in a number of our presentations because it represents the work of the team, the camaraderie, the warmth and collaboration that we all built together. This was on one of our field trips that we discovered this beautiful shell. We put it back. It got to be used perhaps by another snail that was growing. And the quote that's here next to it is one of the really valuable quotes out of the UNESCO recommendation on open science. It was adopted and endorsed in November 2021, which seems just like yesterday, by all of the UNESCO countries. And this quote really embodies what I want you to understand. For science, for research, for open science, you both contribute and take advantage. When you embody these practices, you learn new practices, you implement them, you help others implement them, you help your teams implement them, there is an opportunity to not only participate in open science, but you're investing information and collaboration for the future, such that what you contribute can then be reused and understood and built upon by others. It's the base of research, and it is the foundation of open science. And this is a direct quote from that document. So for Parsec, we embrace this idea of a spiral, and you neither live in one space nor do you stay in one space. So imagine this very center of that spiral is you. You as a researcher, a learning researcher, an early career researcher, perhaps a more distinct with researcher, and we're all learning new things. And you can make yourself more discoverable, more visible, and get recognition using researcher-oriented open science practices. The next level is your teams, the research team or the project team that you're on, the lab that you're in, and what does it mean to practice open science practices there? And we're going to talk about that a little bit. And then your community, let's say atmospheric sciences. I know the Amazon FACE community will be very keen to work on and collaborate with a number of atmospheric areas. I'm sure there will be also soil and so much more. And what are those disciplines deciding on and working on? That area is still in development worldwide, but it is showing some really great promise on commonalities across the disciplines worldwide. And then beyond your community, especially multidisciplinary work. Parsec was multidisciplinary. What does it mean to have those cross-domain challenges and just be able to talk the same research language? So you move in and out of this spiral, not in a linear way, not in a one-directional way, but both directions. You learn something about yourself, you apply it, you learn something for your team, you apply it, maybe you go back, you go forth, you do better, you make things happen that was difficult before, and now we have the right tools. So it is very interesting how we think about these practices and this concept of a spiral. So the snail continues. Different angle, same snail. So this is the very beginning. This is the researcher, and we're applying the practices for discovery of you and your work, your visibility, your recognition. And we're particularly looking at digital objects outside of a peer review publication, but also linked to a peer review publication. Digital presence is you. It's using a persistent identifier such as the ORCID. So if you don't have an ORCID, I challenge you this week to get an ORCID. It's spelled not like the flower, and I realize I'm talking to people who speak Portuguese. So I don't know if somebody can pop in the chat a link to the ORCID website for me, orcid.org. So get your ORCID, and I'm going to show you a few techniques that you can use to make it work for you. And you should share these techniques with your peers because there's a way to optimize your presence that will help you for the long term and help others find you. And then, of course, data sets that you create as observational data, that you create as aggregated from other data sets. What does it mean to make sure those are documented and cited? I won't talk as deeply about that, but I'll point you to the materials to go in more detail. And the same for software. Similar challenges, not the same. Software has different licensing. Software commonly and preferably has version control, and it usually has a lifespan of evolution that's very different from data. So important to keep those separate. And there's materials for you on those too. The second level above yourself, that's your team, your project team, your research team, your lab, what it means to work openly and collaboratively. When we start working together, or when you join a lab, there's usually guidance. This is how we behave in the lab. This is what's expected of you. This is where you log your information. These are the tools you use. We will train you on how to use the equipment. And what we're recommending here is that you add to those practices what it means to work openly as an open science team. So that very first bullet will be establishing an open science agreement, which is not a big deal. I don't want you to get overwhelmed by it, but something to incorporate in your research lab as you're adding in open science practices. What it means to determine the best resources and provide that education for your teams on using those. So that's the second bullet. And the third one is the developing checklists for your team, because these are going to be new practices. And I don't know about you, but I'm not really good at adopting new things. I do what I know because it's easier on my brain. But when I need to do something new and I have to force myself to be good about it, I need someone holding me accountable. I need someone to say, hey, did you do this? Until it becomes a habit. And these checklists help yourself and your research team to adopt these new practices, just like any human doing anything new. So it's not going to surprise you, but it will perhaps make you think twice about how research teams can evolve and how you can take them forward with improving practices. And then let's see. So this is the community. This is an area I'm actually working on with others in a very large global collaborative way. And Professor Carrera, I haven't spun you up on this new grant that we've just won, but it would be great to partner with your teams on this, building community resources. For instance, we're going to look at hydrology, seismology, and oceans research first, and the data sets that are commonly used there, and determine preferred repositories, preferred metadata, preferred vocabulary, and team with the section leaders for AGU, division leaders for EGU, and division leaders for JPGU. And of course, other societies are also welcome. And in doing it like that, which is unprecedented, nobody's ever done it like that. So please hold us in prayer, because it will be challenging. But we want to lift up the good work of others and make sure researchers like yourselves are learning about the practices that are benefiting the community and allowing data to be more interoperable, easier to share, easier to reuse, and benefiting you directly. So you can see that give and take. If we can all work towards common methods, protocols, practices for data management, software management, then it benefits us because it's easier to find that data, determine if it's useful for our work, and then and actually use it to build upon the research that we have. How many of you, if you haven't yet done this, I can assure you it is difficult. You try to find a particular type of data, and the first question is, where do I look? And there's no common place to go look. It's hard. You have to ask a friend, you ask your supervisor, they know of a certain set of resources, but it's hard to know them all. And so much of our research doesn't look at borders, national borders. So the data captured in Brazil, well, where's the data captured in Peru, right? Is it in Peru or is it somewhere else? So you can imagine how difficult it can be. And let's just end that. We have enough technology that should never, ever, ever be our problem. We should be doing that quickly and moving on to our own research projects, our own research thinking, because you're all brilliant and you're all going to solve problems that no one's ever solved before. And if you have access to the data you need, the software you need, and the tools you need in a faster way, then you're gonna help the world. And that's what matters here, is that we're able to deal with these very complex challenges and phenomena that we don't yet understand. So, haha. So here is a website for you. Somebody confirmed this is Portuguese, please. I'm pretty sure.
Please.
Very, very good. I did not translate. Somebody from Professor Curra's team translated it for us, but it is on the AGU webpage. And so you can grab that QR code, and this is where all of the checklists and an entire compendium of the materials are linked. They live in Zenodo, but they're linked here for easy access. And we do have Spanish and other languages that you can go up into the resources tab in order to find and identify. And yes, so if you miss anything, everything I'm talking about is here. You just don't have my voice to go with it necessarily. Let's start. We're gonna talk to you about, and I'm gonna watch my clock because I can definitely talk a long time. So far, so good. Let's talk to you about the researcher, and we're going to do a deep dive on that ORCID and digital presence. I will scoot through these a little quickly, just so that we have time for more questions at the end. But why is it we call it digital presence? It's how you are found and understood on the internet. So I'm not talking about your Instagram profile. I'm not talking about that, although you can share research there. I'm talking about the more professional ways that we are connected, that have authority and trust. Those are the tools that I want you to take advantage of, specifically your ORCID. So by getting that working for you, the muscles of your digital presence, you will have more visibility, and people will be able to find you and the materials that you've created and your team has created more easily. So this is what I want you to take advantage of right now. And get used to it being part of what you update and check on every few months to make sure it is current and has all of your information. So who looks? Well, frankly, I do. I look for people to help on all kinds of teams. To be quite honest, early career folks on open science is my preference. You all understand what it means to share. You will all understand what it means to work collaboratively in ways that when I was your age, we didn't have tools like that. So it's not as easy a concept for me. So you have the understanding and value already baked into your psyche because of how you grew up and what was available to you as tools now and into the future. But when you're using these professional applications, this is where collaborators will look. This is where potential folks looking for postdocs will look. Journal editors hunting for reviewers, they look here. AGU has just started to incorporate the ORCID context into our search criteria on our website. So it behooves you to get yourself updated. Others are doing the same. So that is one of the reasons. Okay. I kind of talked about this. Why do you care? Ability to discover, increase citations of your work because people can find your work, increase opportunities to collaborate because people can find you, etc. So let me keep going. So this is a fun example. Mark Parsons used to be the Secretary General of the Research Data Alliance, an international organization. He's currently the interim director for the Earth Science Information Partners. And on the day that I did this Google search, he has I don't use my name. My name is a little unique. So my name doesn't render this kind of issue, but Mark's does. None of these people that came up from Mark Parsons are my friend Mark Parsons. None of them, not a one. So using Google to find people is pretty much useless, especially for common names. And there's common names in every country. So I'm absolutely certain that you have the same situation. So over here on ORCID, so orcid.org, I typed in Mark Parsons, and he's still not the first one, but I can quickly identify him based on his affiliations that this is the guy that I'm looking for. So we have a persistent identifier. It's that number on the left. It has a URL that is persistently resolves to the information that you create in your web page. So let me show you. This is his web page. I don't remember which day I took this screenshot because he has since now added the employment of ESIP. I suspect he updated. You can look. You can go look at it. You can look on his ORCID page to see what it looks like. He probably now has the ESIP interim director position in employment. But this is where I would go get, like if I was going to introduce you on a talk, I would come here to get your bio instead of bothering you. I would come here to check on all of your publications. I would look for your co-authors to see the kinds of folks that you work with, and maybe I'm interested in the sort of team that you're working on. So this is such a useful way to let folks know where you're progressing, what you're interested in, and have an opportunity to take a look at all of your work. So this is for those of you familiar with knowledge graphs. What we're going to do here is kind of build a knowledge graph. So when you publish in a publication, this is one of AGU's journals, AGU Advances. This is one of our flagship journals meant to share very impactful research, but honestly, I mean, Earth and space science and environmental and climate science research is all impactful, right? But here we have a corresponding author, Tianzi Liu, and they have included their ORCID as part of their publication here. And when you go to their ORCID page, you'll be able to see this publication associated with their ORCID ID, thus connecting their paper to their ORCID. There is a way for you to automate the update of your ORCID. To do this, I want you to do that. It's once and done. You do it in your lifetime. Have all of your friends do it, and people who might not be your friend, I'm sorry, all of your acquaintances do it, especially your friends, because this will make life so much easier as it will populate your ORCID with all your peer-reviewed papers, and you can do the same thing for data sets. So here is my ORCID. I suspect this has aged a little bit because I'm not sure that Notebooks Now paper is the last one I put up. It looks like the screenshot was from 2023. But you can see it says source and then a green check mark and then Crossref. Crossref may be a strange name for you, but you're about to meet the gentleman from DataCite. Crossref and DataCite are registry agencies for digital object identifiers. Those are persistent identifiers for scholarly works. You want to know this. Crossref is used by, and I'm going to say this simply, if you're an expert on these registry agencies, this will cause you some angst, but I will say it simply. But Crossref services every peer-reviewed journal for every language except the Asian languages, because they have special requirements. And that makes sense, right? Like there's 2 registry agencies in China, 1 in Japan, 1 in Korea, and I think I got them all. But here it's not only English, but every other language journal, and it's a lot. It's a single point of connection, and every journal, just about every journal, when you're registering for a digital object identifier for your paper, like the one for garbage in, garbage out, that was in Nature. I'm very proud of that. Took a lot of work to get in there. And that digital object identifier points to that paper. Now, don't be mad at me. If you go look at it, it's not open. Just let me know. I'll send you the file. It was open and then they closed it. It's a commentary. I don't have control over it being open or not. It was open, but I'm happy to give you the file. But generally, we should all be publishing openly with all of our papers so we can all read them no matter who we are. So my apologies for that not staying open, but I'm happy to share the file with you. Okay. So what else can you put in your ORCID file? Well, there's a huge section for education, all of your work history, whatever funding you've received. There's a peer review section. If you peer review for anyone, please do that. That's a great way to get to know how research is actually formulated, to have an opportunity to do peer review. And I believe that early career folks should absolutely be peer reviewers. You see things differently than others. All of your presentations, data sets, software, any other digital object, IGSNs, physical samples that are represented as IGSNs or RIDs. So this is fantastic. It's a hub. It's not your CV. It's like a hub. Everything should be connected here, including your CV. You should have a place where your CV is digitally, and you should connect it here, and then everybody can find it. So here are all those sections again. You can take a look. I'll keep going. And I'm going to show you the, okay, I don't have a link here for you to see this, but I will give you a QR code where the link is available. Let me see, let me get to it. Auto linking, when prompted, include your org. So this particular slide talks about no matter what, get your ORCID in here. If your publisher requires ORCID for the first author or corresponding author, and it's optional for everyone else, don't skip that. That you're not doing your co-authors a favor. You want to populate the ORCID for every single person that you have on your papers. That is a best practice, no matter what, if it's optional or not. You want to actually do that. Otherwise, you're pushing the work to that person for them to get that paper connected to their ORCID digitally. It's doable, but it's rude. Like, don't make them do it. You are the corresponding author. You should add their ORCID in. That's what I'm saying. It's the right thing to do. Okay, here, please grab this. This is a postcard that will also connect into the checklist for digital presence. The Portuguese site has the information for digital presence that will give you the link to how to automate the connection to Crossref and DataCite. So here's your action items today. Number one, if you have an ORCID, check it out, make sure it's up to date. If you don't have one, get it established. Number two, get your automated connections between Crossref and DataCite. Here's a funny thing. You can do it for DataCite today because of how that authoritative link happens. But unless you already have a peer-reviewed publication with a DOI, you're not going to be able to do Crossref until you get one. So if you have one, do it. If you don't yet, remember to do it then. So I don't know why they did it that way, but they did. Okay, I thought there was a third thing that you had to do. What was the third thing, people? What was the third thing? Okay, I don't know. We'll give you more homework in a second. Hopefully everybody has this. If not, okay. Now we're going to move on. So if you have any questions on digital presence, now's the time to pop those into the chat so you don't forget them. And we're going to move on to teams. This one's a little bit shorter. And I'm checking the time. Yep, good. So teams. So we talked about creating an open science guidelines for the team. What does it mean to think that through and determine what our open science practices are going to be and codify those? We talked about making sure that the team has the resources that have been determined and that we're clear and everybody's using those same resources. And we're going to give you checklists to help people with changing their behaviors so they remember to do the things that you just told them to do in number 1 and number 2. So yeah, I'll give you a story and you're all going to understand. So there's a new app that comes out. Everybody loves it. No, not everybody. There's this one person that always adopts the new app first and wants you to join. And you're like, no. I already have accounts on these 10 other apps. I can't keep up with those 10. Why do you want me to join this 11th one? So imagine that same problem when you're doing your research. You have already configured your laptop to optimize how you do your research, how you bring data in, the software that you use, how you analyze it, the visualization tools. And now you join a new research team where they're going to do it differently. And you're like, yeah, no, that's exhausting. I can't think about it like that. That's too much. This is the issue that we run into when new teams come together that have previous history with other teams. This is the rest of your life. Like, you may not have hit this yet, but you're gonna. There has to be some understanding on collaboration and common tools. So participate. If they say, hey, what tools do you use? Make sure everyone understands what you're using and why, so that when we're comparing to everyone coming together, which are the most open, which support our goals best, and then there's a decision that's made, hopefully in collaboration with everyone. Someone's going to lose out, right? Like, it's going to be 1 and not 2, probably. It might be 2, but that's hard. Somebody's going to have to transform, and that's it. There's a problem when you pick 2. Some information is going to get lost. So you had to make that decision painfully. Let's say there's 1. Someone's going to have to learn how to use that. So some grace, some kindness. Let's make sure we get good training and we understand that grumpy moment where, okay, well, all right, I'll be the one that learns the new thing, but I'm not happy about it, right? Like, that will happen. And having processes and support in place to encourage the alignment and get everybody all on the same page will benefit your project for the rest of your work. And that's the benefit. So it is hard. Okay, so there are, we talk about these 3 things. So the very same thing we just talked about before, we talk about them in this concept of prepare the team, equip the team, and then make sure what the team did is preserved, backed up and preserved. So we're not replacing any research processes. Like, what you're doing, you should use open science optics to make sure it's the best possible thing. We are adding concepts to what you're already doing. So the code of open science practice. So open science teams for practice, develop and use open science practices for your lab or research team, improve your team's data and software management practices, codify these practices in your team's code of open science practice. I think the word practice is said so many times. I realize it's probably a little redundant, but okay, we'll leave it. Equip the team. So this is a list of the resources and guidance for the team, but it's also the education and support to do those things and use those things. Ensure your team has access to those common resources, the guidelines to use it, that you collaborate, and this is where your transparency and openness happen. I could give you examples as to how this could go bad so many ways. I'm sure you all have maybe some potential examples. It's worth the time and energy at the beginning of your work to figure this out. And then your preservation checklist, ensuring that your digital objects that are created or used are fully documented and preserved for the long term and made openly available to the team. To the team. We're not talking about international publication. We're talking about internal team use. So imagine, so you're at the University of Sao Paulo. I'm here. University of Maryland is near me, so let's pick them. And and perhaps you all collaborate. Maybe you're thinking of someone in Maryland, And you've got 2 different servers, 2 different backup systems, 2 different everything. How are you going to make sure all of these things are happening in a way that there's no risk to the data that's created? There's equal access for both teams, that there's no, I'm sorry, you're not a University of Maryland faculty or student, therefore you don't have access. You have to navigate this. Having inequitable access is not okay. You have to have equitable access. Okay, I think I made my point. Okay, so this is all I'm gonna have 1 page for each to give you a sense for how deep it goes, and then you have access to the checklists on your Portuguese page. Okay, so there are 5 pieces to the Code of Open Science Practice. Let's walk through those. Who's on your team matters. You have to, the people on the team have to be open to the fact that you're going to practice, that you're going to do this research in an open science way. So when you add your team members, be really transparent on the expectations and that they understand what they're going to be doing. I don't want to say don't. It is not nice to pull somebody on a team where these new practices are going to be done if they are nervous about, they're your software developer and they're nervous about people seeing their sloppy code. That's not nice, because that's a vulnerability and people get really upset because there's not a, it is unusual for us to do peer review of somebody's software code. And yet on this team, we're going to share code openly for the purposes of making it the best possible code representative of our team. You see how that all works? So therefore, you figure out when software needs to be shared. Like, let's say before you publish the paper, somebody has to make sure the team saw it, walked through it, and it's going to be okay. And then, because you're practicing open science, you will then make it open and available associated with publication at that time. But you don't do it, don't expect somebody to make their code open for a publication where you did not help them create the best possible code for that moment. That's not, that you want to support them. You want to give them feedback, improve. Maybe it's just the documentation. Maybe you have a second person who's a developer that you could do a desk check to make sure the logic makes sense. But you should realize that coders feel looking at their code as being a vulnerable moment, and not to forget that you should really think that through and not make them uncomfortable. Okay, that was an example, I think, that sort of walked through each of these 5. The third one there, team task and responsibilities. For instance, that would be, let's say someone's going to make some code or a model, and you're going to be you're going to test it out. But before you test it out, you all made the decision that you were going to talk through how the model worked. And maybe there would be a desk check at that time for one or more folks to sit with the person who created the model to walk through how they developed it. So someone has to schedule that and make sure it actually happens, and not forget that this is what we're going to do, even though it might be new to the team to actually do these things. Okay. I think that's good. Let's go on to equip. So this is where we make sure folks are using those new tools. All right, so I gave in. I'm going to use the new tool. That's the example I gave you before. So first of all, I forgot where it was. I forget. What was it called again? I forget. So that first one there, establish common team resources. Give me a place where I can go and click the link or get the information or get the user, the manual or whatever I need. Make it super easy for me so I don't have to go hunt it down, because I'm already going to be grumpy. So make it easy. And then reminders and milestones. This could be like if you're onboarding someone and you want to make sure that they are also comfortable with the tool, that you make sure they take the training that's available, that they had an opportunity to practice so that they're comfortable when they start to ramp up to support the team. And then make sure that I, Shelley, didn't go back to use my old tool because I was just too frustrated and nobody checked on me to make sure I was okay. So those kinds of things. And then ask me, what was frustrating? How could we improve your experience? That's number 3, improve practices through use and feedback. What was frustrating for you? Oh, I just needed to set aside a couple hours and I didn't do that. And then I tried to do something like, all right, well, that's on me. I should have set some time aside. So we can include that in our guidance for you. Hey, you're going to need about 2 hours to get comfortable. Please, do you want us to set aside some time where we're sitting with you while you're getting comfortable? Yes, maybe I would like that. Maybe somebody I know really well could sit with me and just, encourage or whatever I need. Everybody's different. Some people just want to do it themselves. Some people want to do it with a team. And then making sure that you're giving attribution and acknowledgement when you are using somebody else's resources. That you're actually D's a little wonky from A, B, and C. Using resources and guidance, but then also giving attribution when you're using somebody else's. If you use somebody on your team, if you're using their data, make sure it's clear that you know you're using somebody else's data, that there's acknowledgement of that, so the value of what was contributed back to the team is understood. Software. There are a number of software packages that are commonly used across many teams. And so if one research team creates something useful that was generic enough for somebody that you know from another team, there's no problem sharing it as long as there's attribution and acknowledgement. And there's an agreement on who will publish it, and that is all understood beforehand. That's a real bugaboo, especially with software being nicked and used by somebody else without that attribution. We don't want to do that. That's not open science, and that, frankly, is unethical. Okay, and then the last one, preservation. This is backing up and preparing to preserve. So, okay, these words can get I want to be really clear because the word preservation, I don't know how it translates into Portuguese, but I want to make sure that we're talking about things very specifically. We're talking about the project. So when you're determining the purpose and criteria for preservation, are you doing your yearly backup associated with your yearly report of your research? It could be that. Are you making sure prior to a peer-reviewed publication that everything that went into that paper is properly backed up and preserved? That's a different criteria. Are you doing daily backups of the workspace of your team so that nothing is ever lost? Because frankly, no grant has time to redo work. Those are all the different levels we're talking about here. And when you're doing this during your project teamwork, then you're preparing yourself well when it's time to preserve those digital objects for associated with a publication or associated with preserving the entire project. So that's what those 3 checklists are. Okay. And we came up on 50 minutes. Man, oh, good. Okay. So these are all of the folks that worked with us on Parsec and beyond. DataCite's in here as well. I think Orchid should be here too. They helped us as well. Yep, they're in the middle. And I'm going to pause right here.
Woo! Shelley, great presentation. We have time for questions. I think Tony will read some questions or we prepare some questions here, but I have some questions. I prepare some questions for you, Shelley. Shelley, what your advice about for example, you are working a project, or you are like Amazon Face. We are working in the different labs working together, and the hub is Amazon Face,
Yeah.
and there are multi teams working together, like 100 researchers all working together, and of course, all of them, they are integrated with the same approach of open science, use some common tools for data sharing between the group, but we need to be um, integrated with all international world, considering the all initiatives that you have in open science in the world. So, what are the basic tools that we must consider when ORCID? We start with ORCID, but others ideas that you think is important to make integrated with all open science today?
Oh, wow. That's actually an incredibly complicated question right there. So we do to help.
I'm not sure if Shelley is down. Please, someone could give me some feedback.
Yeah, she's down.
Okay.
It's
Yeah, just
still
wait.
good.
It's important. Please, Ton, give some directions about how people can make questions, and I don't know if people they know how to use this question and topic
Question
here.
and answer. Yeah, I will make it clear. Just the moment. And again.
Yes, we have some instructions up in the chat here. Please feel free to put your questions. I am Tony. Will read these questions for Shelley before we start new keynotes. Okay. I don't know if you have some questions. Tony, if you can read some questions, please feel free to continue. Hey, Shelley,
I
is
am so.
everything?
I switched networks. Shall I answer the question you had before? Very complicated question. Okay, so super complicated question. We do have some additional materials about preparing a digital and data output management plan that walks you through thinking both directions, thinking capturing Earth observing data, as well as what it means to then share it later. And what you want to consider, and it would be good to have a data manager helping you with this, even if it's just to get your DDoMP set up. But you want an expert on each of these data types, meaning the preferred metadata, preferred vocabulary, so that you can integrate into international data holdings as well. And then what is coming from the instrument? Does it have everything it needs to be able to get there? And then holding that metadata all the way through, so that the researchers have the advantage of all of the information fit for purpose, all the uncertainties that will be valuable for their work. So it is an excellent first question to ask, because you would want to do that for each type of data, and then make sure each of your labs are on the same page, that they understand what the goal is. Can you unmute?
Yes, Tony, we have another question. Please, could you read this question?
Sure. The question is from Marcio de Aguiar. I work with a medical imaging data that is legally restricted and can't be shared openly. How should a code of open science handle the distinction between open data, which I can't provide, and open model weight is sharing the reproducible training code without the raw data considered sufficient?
That's another excellent question. Boy, you guys don't give me softballs. So medical data, of course, is protected. Health data, human data is protected. So let's something worth saying out loud is open is not binary. It's not either open or closed. Open is actually a bit of a continuum. It drives me a little crazy that we chose the word open because it is kind of like a light switch, right? It's on or it's off. And in our world, that's not the case. We have to have these other spaces that we work in. Medical data is one of them. So your team, let's say you have a team of 5. I suspect all 5 of them have access to the data that you're using, even in a protected area. You probably have done that for them because they all need to have access. So it is open for your team, and that is perfectly okay. That fits the bill. You will never make that protected data open publicly. You won't, but you can make it well documented, easy to understand, and interoperable with the other data. So you kind of think about it in layers, and you can assign persistent identifiers to the data that you did use. If it's important, you can anonymize it, or there's some recommended practices within healthcare data, depending on what the research is. Sometimes you aggregate it, like census data is aggregated. Sometimes you anonymize it, so I would follow those practices. But then you asked about models. There's work on model transparency in the Research Data Alliance. I would point you to that for those recommendations. And Professor Carrera, I think you'll, trying to remember what the name of the group is. I can connect for this person on something that would be valuable to inform them on those decisions. There's another group that's working on when you cite a model, like a peer-reviewed publication that you're going to publish your model and you want to write about it. What are the pieces you need to include in order to be as transparent as possible? Because models are very different. I can point you to that. So now you gave me 2 things I have to find for you. So let me write those down real quick. Model transparency and then model citation. And these groups all work together. Okay, so I will find those 2 resources and put them in the chat as we're finishing.
Awesome. I think we have time for one more question. I don't know if you have other questions. Tony, do you have?
We don't. Looks like the people is a bit shy today.
Oh, does anybody online not have their ORCID? So don't forget your homework. Get your ORCID and get yourself automated. You can create a team. So for Amazon Face, there's a way to create an ORCID team where you can have all your ORCIDs together. I'm not sure what the best way to implement that is. But,
I don't know about this. Wow. we are checking this. Awesome, Shelley. And it's I think it's important for every researchers that work with us, every early researchers, that they must understand, because they must have digital presence. They must start with ORCID. And but it is a journey that we must to follow, because like you show us the caracal, yeah, we are spiral. This is a spiral process. You just started in the ORCID, and they are going to follow, and you have a word to a lot of have a challenge, a lot of challenge, but you must start with ORCID. This is the first step. This
It
is
really is. It really, everything built off of that. And a matter of fact, you're one of the things I share with people is put on your calendar quarterly reminder. So every 3 months to check your orchid. And I actually have not done that. So you can yell at me. I haven't looked at my orchid in a long time. I haven't, I've won 2 grants in the last few months, but they're not on my orchid, which is stupid. It's
Yeah.
just stupid. It's such an easy way to let people know what's going on. And then, for instance, you can, LinkedIn is also very helpful. So, but that's more social. So I should go to LinkedIn. I should write about the grant. I should point to my orchid or the grant webpage to highlight the work. You know, it's just simple things to do to let people know what you're up to.
Yeah.
Yeah.
Yeah, and it's interesting that you told us about the ORCID is like a hub, is like a data portal that you're aggregating, like your
You're
uh,
hooking it in. You keep hooking.
projects,
Yep.
people that work with you, and the institutions. You have ID for institutions. You have a lot of
Yeah.
IDs that are indexing in the
Yeah.
world. They are aggregated with your in your ORCID. This is awesome. This is
Yeah.
perfect.
Here's something for students that's really good. Make sure that you use you all are learning. You're going to proceed with your education. I am delighted if you can stay with the University of Sao Paulo, but you may decide to go somewhere else for your master's or PhD. When you lose access to your University of Sao Paulo email, you want to make sure that your orchid has another email. So put your personal one there. You don't have to make it public. You can keep it private, but make sure you still have access so that you can get to all of your stuff, even as you transition. You know, and that's true for me at AGU. Should I retire or should I? I'm old. I don't. I hope I don't have another job. I hope I stay here. I just want to retire from here. Um,
Awesome.
Tony, is there another question?
Yeah, there is. Marcio has another one. In deep learning teams, we often distinguish between the data engineer and the model architect and the domain expert. Does the digital object checklist break down responsibilities by role?
Oh gosh, I think so. Deep learning. There were 3 things. Can you say them again?
The three, data engineer, the model architect, and the domain expert.
There's no reason you need to necessarily add other people. You can take a look at the practices that you want to include. I could see your data engineer might be interested in certain elements, and then you would assign them to monitor the metadata, monitor making sure the links are there, monitor them, you know, whatever they are most interested in. Your model architect, uh, they actually need the data engineer to be effective, right? So they're able to create models from data that's well documented. So they would be very keen in maybe giving feedback to your data engineer. Hey, this I'm missing some information. Here's there a way to fill it in? That's no different than what you're doing today, right? That's not like a new thing. But your model architect might be interested in taking a backup at certain moments. I want to make sure that we have this information saved because we're going to experiment going this direction, and we may have to come back and go another direction. And I want to make sure that this moment in time, we can come back to this moment in time. So that would be a request to, hey, let's back up this moment, whatever. And they would say, it's these pieces, this configuration, this forcing factor, this whatever went into the model that you need, all the data, of course. And then the domain expert would confer, like if it is the best possible data, it is, yeah. So you're using those roles with the optic of an open science mind to make sure you're including everything? That's a great question.
Shelley, I don't know if you have more questions, but I don't know. Is there, Tony?
No, there isn't.
Okay. Shelley, thank you so much for your presentation. We are so happy to see you again. And I think all of these people, some of them, they know you for some presentation here in Brazil. And everyone is very happy to see you and have this presentation, very brilliant presentation about the how you can introduce everyone in the every researcher in the digital world. This is very important. Thank you so much, Shelley. I hope see you soon.
You're welcome, and you do good work. Do good work. Okay. Bye.
Bye bye. Thank you. Thank you, Shelley. So we are going to continue our workshop. We have other keynote. Next keynote is from Mohamed Mustafa. Mohamed Mustafa, he is a community specialist at DataSite. As Shelley introduces, DataSite is important institution for indexing um, uh, data sets in the world, and you have unique IDs for all data set the data set in the world. So Muhammad is talking about the how is the what is DOI, digital object in digital object. So this is the Mustafa will talking for us. Mustafa, now he is traveling in, so he just recorded his presentation for us because he is in the flight exactly in this moment. And but Mustafa prepare just send us a presentation recorded, and the questions we just will. If you want to make some question, you can write this question. You can send to Mustafa, and the presentation of Mustafa will be available during the presentation. You can access your the slides too, and maybe the slide the other presentation the other slides will be available for everyone. We during the when you finish the workshop, you send the link of all presentations. So is everything ready for Mustafa presentation, Tony?
Yeah, it is.
Yes, awesome. So you can start, please. Start the presentation, Mustafa. Thank you.
Hello, everyone, and I'm very happy to be here today with you. I am Muhammad Mustafa, Community Specialist at DataSite. And yeah, I really want to thank Dr. Pedro and the University of Sao Paulo for giving us this opportunity to share our perspectives with you today. Again, I apologize if I'm not able to be virtual live with you because I'm currently traveling. And in my presentation today, I want to focus on DataSite, our community, and how we are enabling open science and also supporting research communities to make research data fair. So yeah, before I talk about DataSite and who we are, and you saw also in my presentation title, I'm going to highlight open science. I really always prefer when I want to talk about open science to start from this diagram that highlights one recommendation on open science. We all know that research communities, countries are different. Each country has its own landscape. It have its own challenges, but these UNESCO recommendations, all UNESCO member states have agreed to adopt and implement in their countries. And as you can see, what the UNESCO team did is they identified 4 important pillars that will help research communities to transit to open science landscape. The first pillar is talking about open scientific knowledge, open access for publications, open research data, and open educational resources. The second pillar highlights the open infrastructure, whether it's the tools, the physical infrastructure that we use to conduct research, or the virtual infrastructure. And I will highlight this particular pillar in more details shortly. And then the third and fourth pillars are about open engagement and open dialogue also across different systems, like indigenous, supporting indigenous people, for example, and also how the community can support the broader community, and the public can support the open science movement. So I will focus today on the open science infrastructure, or open research infrastructure, which the UNESCO defines it as the shared research infrastructure that are needed to support open science, and at the same time it will serve the needs for different communities. So when we talk about open science infrastructure, we refer to, as I mentioned earlier, the physical infrastructure, the major scientific equipment or set of instruments or tools that we use. But we also talk about the virtual or the digital infrastructure. So here we are our open access repositories that universities are maintaining to disseminate their wide range of outputs and the resources that they produce. We also talk about publications platform for journals. We also talk about specialized repositories like data repositories, electronic thesis and dissertation repositories. All these different digital systems that we use at our research organizations to disseminate research outputs and resources. So if your university is currently running any of these systems, so you are considering also having an important part of open science infrastructure at your university. And just to add to that, also, the UNESCO highlighted that open science infrastructure are often built by non-profit organizations, and these non-profit organizations will be governed, sustained, driven by their community of members who join these associations and help them to sustain their services to ensure a long-term sustainability for these organizations. And of course, the ultimate goal for all of these efforts that we want really to increase the transparency, to enhance the equity and fairness as well. And all of these points together will help us to have a trusted research ecosystem, as I will explain in my upcoming slides. We see also in the 2022, in the following year, after publishing these or releasing these recommendations, the UNESCO published this statement that was dedicated to open science infrastructure in particular. And yeah, again, they highlighted the importance of maintaining these digital virtual infrastructure, such as open access repositories, specialized data repositories as well. But what we can see really very clearly, what was mentioned at the first page of this statement, and I included the DOI here. If you want to access the full statement, it's available at the UNESCO website at different language as well. So they highlighted at the first page, and I quote the following the statement. The critical component of open science infrastructures allow unambiguous identifications of scientific items. How we can do that identification? By unique persistent identifiers. Why? Because they provide open and standardized services that will help us as a research communities to manage and provide access, analysis, federation of data to the scientific output. So we can see very clearly here, sorry, very clearly here at the first page of this statement, the UNESCO is advising research communities to adopt resistant identifiers. They also did cite at the first page of the statement some examples of these bids. So they highlighted, for example, ORCID IDs for academic researchers and contributors. They also highlighted data site DOIs for research data and other outputs as well. And they mentioned also research organization registry. So yeah, I just wanted to start from these global guidelines, as I mentioned, that was mentioned in the UNESCO 2021 Open Science recommendation. So when it comes to persistent identifier, so what we mean when we talk about bid usually is a unique alpha numerical string that usually refers to a digital resource So when we click on that identifier, we'll be redirected to a landing page that is always open, and that landing page will have a metadata representation about that resource. As you know, we have several types of persistent identifiers. We have worker IDs for academic researchers and contributors. We also have research organization registry for research organizations and universities, ROR IDs. And we also have DOIs, or digital object identifiers, for research outputs and resources. So yeah, today I'm going to focus more on DOIs, but I will also speak more broadly when it comes to the trust and building trust in the research ecosystem about the persistent identifier metadata and how it will help us to build a trusted research infrastructure. So in terms of DataCite and who we are, so we are a global community of research organizations. All of these research organizations are coming together because we all share a common interest. We all want to ensure that all research outputs and the resources are openly available and also connected. And why we want to connect all research outputs and the resources? Because we really want to increase the reusability of these outputs, with the ultimate goal, of course, to help advancing knowledge across different subject areas and also between different disciplines and also across different times, between our times and future times as well. And in line with the UNESCO definition, DataCite is a non-profit organization registered in Germany since we started in 2009. So within the DataCite community now, we have over 1,700 organizations that are part of the DataCite community who are joining us to register DOIs for a wide range of outputs and the resources, as I will explain more in the upcoming slides. And we also, when we talk about the organizations that is currently joining DataCite, we see a wide spectrum of organizations, from universities and research institutions to national libraries, for example. We see also think tanks, we see the museums community, we see the National Research and Educational Network. So we see a different spectrum of organizations. All of them are coming together because, as I mentioned in our introduction about DataCite, they share that common goal where they want all research outputs and the resources to be openly available and connected as well. We have members across 66 countries, and just very recently, we also crossed the border of 100 million DOIs registered by our members. And just to give you an idea about how DataCite DOIs are being used, we had like over 650 million resolutions for our DOIs in 2025. So yeah, this graph shows you also the interest from the community to join DataCite as an association, and also the interest from the community to register DOIs for their wide range of research outputs and the resources. So we can see in the last, I would say, 3 or 4 years, the number has been growing a lot. The total number of DOIs registered over the year in 2023, 2024, and it's almost doubled as well in 2025 for this year. In terms of our services at DataCite, we provide infrastructure that will allow DataCite members to create and manage DOIs, and also they can register these DOIs and provide rich metadata information while registering it. And we allow them also to register DOIs in a wide range of diversified outputs and resources. But we are not only a DOI registration agency, we also build integrated services to improve and enhance the research workflows. And we also facilitate the discoverability and increase the reusability of the research outputs and resources that our members are registering. We all know the importance of enhancing visibility and discoverability. So yeah, this is one of the key services that we provide at DataCite. As I mentioned, DataCite DOIs are suitable for a wide range of research outputs, resources, and also research activities. So yeah, we can group them into different parts here, as you can see. So the materials that are associated with a specific research process, such as research data or a model or a collection, or even a software script that has been written while conducting a specific research process. It can be uploaded to the website and or to your repository, and you can register it with DOIs. The associated images and models as well can be registered with a DOI. We also support registering DOIs for gray literature. So I'm sure you agree with me, our universities are producing a good number of theses and dissertation. We have like master students and PhD student as well that will produce these outputs. These outputs will take a lot of time, effort from them to conduct, so it's worth to become visible, connected with the DOIs, with rich metadata information to increase the visibility of these outputs as well. Along with that, we also support reports, conference proceeding, newsletter, preprints, journal articles, all of the valuable outputs that usually institutions will be disseminating them through their institutional repository. We also support registering DOIs for a wide range of physical objects like samples. So a wide range of samples that can be registered with DataCite DOIs now. We also can, members can register prototypes, and also even artworks and artifacts can be registered with DataCite DOIs. That's why, for example, we see the museums, the community now is joining DataCite to register DOIs for their digital collections and their artworks as well. And recently also we started to support registering DOIs for research activities. So when we talk about the grant or the awards that the funders will be issuing, so these research activities as well can be registered with the DataCite DOI along also with research projects. So yeah, this diagram can show us the DataCite metadata by resource type. So as you can see, one of the most used resource type is data set. That's why we have the word data in our name. This is how we started. But as you can see also, the DataCite metadata schema supports registering DOIs for a wide range of outputs and activities. So if you are listening to us today and you are already a DataCite member, for example, yeah, please make sure that if you have these diversified outputs, I'm sure at your university, and you're really publishing and disseminating them, it would be really good if you also can use different resource types as well and register these outputs with the DOIs. But if you are not and you want and your university is already producing some of these outputs, it would be really good if you want to explore joining also our global community so you can connect all of these different outputs and the resources. So in terms of why DOIs and bids in general, I would say are important because they will really help us to make our research data fair, and we'll dive into this more in our upcoming slides. And also we will help us become more and more aligned with the open research practices and policies, but they will also help us to connect our research outputs and the resources with a global ecosystem. They will boost also the visibility and discoverability. We all know the ability to retrieve the DOI's metadata or the persistent identifiers in metadata, and how this can play an important part in increasing the research outputs visibility as well. And we all agree, I think, that journal articles, which are currently receiving a huge attention when it comes to research reporting, is just the final output or final product for a long research process. During that long research process, researchers will are producing valuable outputs as well, like a research report or a data set or a presentation at a conference, or like a different or a preprint, for example. All of these outputs should be also visible, should be connected with DOIs, should be registered with rich metadata informations, because it's a contribution from researchers, and it's also an important part of the scholarly record. So when you assign DOIs for dissertation and thesis and reports and research data, you are also increasing the recognition of these research outputs as well, beyond the current attention and recognition that is already given to the journal articles. And overall, this will help in increasing the opportunity for citations. As we all know, like more visibility and discoverability can lead to more citations. And overall, I would say improving the institutional and increasing the institutional impact as well, because we all know when all of your university or all of your institution output are more visible and more connected, this will lead to increasing the overall impact of your institution. And now I want to focus on how we can build and enhance the trust in the research infrastructure using metadata. So, first of all, what do we mean when we talk about bid metadata? So we always refer to the information that will be collected during the registration process for a DOI, for example. And that persistent identifiers metadata is very useful when we make it rich and when we provide descriptive information as well about the digital object that we are registering, because these descriptive information will help us to identify and access also and know more about that digital object in various contexts. So it will enhance identification, discoverability, and the ability also the interoperability. So for this output to work across different systems. And most importantly, it will also enhance, as we will see in the upcoming slides, the trust in this open infrastructure. So I just wanted to refer also quickly to our metadata schema structure at DataCite. So we have 6 mandatory fields. So we talk about the identifier, the DOI itself, the creator, the title, the publisher and publication year, and the resource type. So these are mandatory metadata elements that you would need to provide DataCite with in order to register a DOI. But we also have 6 recommended and 8 optional fields as well, such as subject and contributor, the language, the format, the rights, the description, the geolocation, and the other metadata elements that you can see also at the screen. So why bid metadata is important? We all know the data management life cycle in terms of storing and managing research data. And we all know also that this persistent identifier will always appear across every phase of the research life cycle, whether it's at the preprint stage or at the collection of the data stage or at the analyzing stage. So providing rich metadata information is very, very important, because these records will become permanent, and the metadata information that you will register when you are like registering a DOI, for example, as a bid, these metadata will always be open, even if your research data is closed for any reason. So your metadata information will always be open. So these metadata that you will provide us with is very important. And the persistent identifier metadata, as we all know, carries also the evidence of credibility. So within our metadata schema, there are different ways when you are registering a DOI, for example, to identify who and how. Like you can identify who did the work and what they did as well through the ORCID ID of the academic contributor who contributed to this work, and you can use also and tag the ROR ID for the organization to acknowledge also the affiliated organization that this person using his or her ORCID ID did this work. And we all know that contributor roles make the hidden labor visible, and we acknowledge the effort of all of those who contributed to make this research possible. So detailed, visible attributions as well for everyone who participated in the research will foster, of course, credibility and also enhance equity and transparency in terms of who did what and who contributed to produce this research output. in terms of who as well, like from a funding and funders perspectives. So this is really important because funding transparency strengthens that research integrity. So you can always add the funder identifier, the grant DOI, the award DOI as well. And you can add links as well within your metadata to link between the funding, the funder, the organization itself, the award or the grant, and the researchers and the outputs as well. And we all know that openly available funding data can expose to us and make us have a clear idea or build accountability in the research ecosystem. Another important point is about the timing as well. So if you are registering a research object within the metadata schema at data site, we can also allow you to capture when that research output was created, when it was reviewed, when it was published. So we have all of these different date type that you can use. For example, you can highlight when this research output was accepted, when it was available, when it was submitted, when it was valid, when it was even withdrawn. So you can have that clear idea about the timeline also and the journey for producing this research output. And we all know that having that verifiable timeline of versioning and revisions and activities is very important. And in the overall picture, it provides us with a context about the research journey that this research has taken. And another important point is the resource output itself. So we have a resource type where you can identify what type of output you are currently registering. And again, the diversity that you can see here at the right side of my screen. So this is the almost around 33 research outputs and the resources that you can register them with data site metadata schema. So this diversity in the research outputs and the resources gives you the opportunity to acknowledge each output that you are producing as well, will give you the opportunity to make it openly available and share it also with the community. So you can, using the resource type at our metadata schema, you can define the nature of the research object. You can also ensure that all components of your research, not only the journal article, but your research data, a software script, even your instrument, you can register them with a DOI, have the ability to be tracked. You also have the flexibility to combine if you want to use the resource type general or just use the main resource type. And it also enables you to constant classifications and discovery. And it can help you also to connect with different relation type metadata to map the research linking. And what we mean here, like for example, like a dissertation cited a journal article or journal article cited a dissertation, so we can build these connections between these two different research outputs. One of the key features as well, and one of the important key features of our metadata schema is the ability to have these related identifiers and relation types. So the related identifier links, you can use it to link to different research objects. So we have like 38 different relation types in our metadata schema. So again, you see this diversity to allow you to provide rich context about the output that you are currently registering. So if you're registering a research data, for example, you can say this research data is cited by, or is supplemented by, or is continued by, or is described by this output, or is source of this output. So as you can see here at the right side, almost like 38 relation types that will allow you to register a DOI for your output and describe it in a very clear way as well using this function. And it will really help us to build that verifiable network of research objects like data sets or articles or samples as well. It also helps us to support the reproducibility and the contextual understanding of the research outcomes as well. And we all know the problem of reproducibility of research outputs as well, and the ability to repeat the research process and get also the data from that. It also helps us to clarify research object and the relationship also, as I mentioned, between these different objects. So if you want, for example, to track citations for research data, and if you are using is cited by or this research data citing this research data, so we can build the connections as well and get the opportunity to track the citations between different research objects. And another important part also is the rights and the licensing information and access, which will help you also to define how your research output can be used. How do you want it to be shared? How do you want it to be cited as well? So it will give you a framework where you can add all of these legal permission, if any, and the restrictions if you want to add as well. And it support ethical reuse and open disseminations as well. So we will help you to add a clear license that enhance transparency and the trust as well. So for example, if you're registering a research data and you want to support, it's a fully open access, and you can use the Creative Commons attribution license as well. So within the rights section, you can add all of these information in a very clear way as well. If you have sensitive research data and you want to make it closed for some time, or you want, so you can add the mechanism also of how researchers can access it if they wish, like they can connect it with you, and you can add all of these information in the right section. So this will help you, as I mentioned earlier, to define how your research outputs that you are currently registered can be used, shared, and cited. And yeah, as you can see, all of these points together will help us to enhance the research infrastructure. But most importantly, also, it will help us to build these different connections. So imagine when we register DOIs for these diversified outputs and we provide rich metadata information, we always include ORCID IDs for the academic researchers, we always include the funding information and include the ROR ID for the funder, the organization who produced this research using their ROR IDs and the diversified outputs as well. So we can build these connections between the organizations, the funders, the academic researchers, and their outputs as well. And even between these different outputs, we can track the interactions and citations and connections between them. Another important point, because we touched on this when we were talking about the benefits of DOIs, is the discoverability point. So we just wanted to highlight very briefly, like the data site metadata information are currently discoverable across different systems and discovery engines, as you can see here on the screen, like OpenAir, and very recently, for example, the 100 million DOIs registered by data site, the metadata information are currently available at OpenAlex. So this was just announced very recently, because at the end of the day, we acknowledge the importance of having our metadata visible and discoverable across different systems, different citations, engines and discovery databases as well. So yeah, for the concern of time, I hope that I'm not taking so much time. So very quickly, I want to highlight, if you want to register a DOI, so this is to non-data site members who are listening to us today and they want to know more about if they are interested to register a DOI with data site. So we have different options. You can connect through our REST API. You can also use our manual interface Fabrica, where you can register a DOI in less than 1 minute. And we have also like a registered service provider program if you wish to know more about that. And as I mentioned, we have Fabrica. So Fabrica is like one-stop service for data site members to create and manage DOIs, at Fabrica, you can find the tools to create and manage DOIs. You can see statistics on your DOI activities, and you can also maintain the organization information. And again, for non-members who are listening to us today, if you are interested to explore joining the DataCite community, we have two options. Like if you are a direct member, you can join us as a direct member, and in this case, you get the opportunity to connect your different systems and repositories with DataCite infrastructure and register DOIs for your outputs. If you wish to start a consortium in your country, in your region, so we are also open to have a conversation with you if you are interested. So there are several advantages for starting a consortia. It's like acting as a sustainable solution as well. It reduces financial barriers. It helps more institutions to join and also help building a trusted and putting open science in action as we highlighted. Or even if there is a consortium in your country or in your region and you wish to join them, so you can join also the existing consortia as a consortium organization. So yeah, so there are different usage pathways if you want to contribute and connect with the DataCite community. As I mentioned, you can join us as an organizational member or work with one of our existing consortia. You can also connect your different systems with DataCite through our API or work with an existing service provider. You can connect with our APIs and explore and retrieve our metadata as well. Or we are planning to have this as a downstream service as well. And you can also always at any certain point, if you want to contribute and share your thoughts and feedback as well. So we have different community engagement groups and discussions. And I will really also want to acknowledge the work that we did over 2024 and early also 2025 with the University of Sao Paulo and Professor Pedro, who is leading this project to the data map in the Amazon. So we are really happy to see this project concluded as we published this blog post. And this is an example as well, because this project was part of a larger project or a larger program called the DataCite Global Access Fund, where we are expanding global access, helping different communities across the globe to develop open research infrastructure to to help them solve problems in their communities or to help build the infrastructure who are not there. So yeah, I thought it's really important to acknowledge the effort that Professor Pedro and his team contributed and dedicated also to make this project a huge success as well. And we are really happy to see this collaboration as well with the University of Sao Paulo. Again, yeah, I wanted to thank you, but before I do that, I want to finish my presentation today with this quotation from UNESCO recommendation as well, where they highlighted that open science is not an option. It's our collective responsibility to ensure that knowledge serves all of humanity. And yeah, again, thank you so much for giving us this opportunity to contribute. And if you have any questions and if you want to know more about our community, please feel free to follow us and email us support@datasite.org. And this is our website as well, our blog, where you can see information on our latest activities. Again, thank you so much to University of Sao Paulo and Professor Pedro for giving us this opportunity to contribute with all of you today, and we look forward to hearing from you. Thank you. Have a good day.
So nice presentation of Mohammed. Mohammed, just show us how is the DataCite operation in the world. It's important to say that if you don't have DataCite, is important we can do data science. We can do open science in the world. So DataCite is a fundamental infrastructure for open science. So it's important for everyone, every scientist, early scientists to know about the data site and the how is the all features that data site could be available for and for everyone and how you can use this very well these features. So nice. So if anyone has some questions about the data site, please we are going to send all these questions for Mohammed. Mohammed, I think, will be very happy to reply us. And in general, I think maybe some of us, or me, and or maybe our team could help to answer these questions. But I think in this moment we can start a new presentation, um, new keynote, the another keynote. So now we are going to start another keynote, the last keynote of our workshop. We are very happy to have here Gir Prakash. Gir Prakash is sorry. Gir Prakash is Army Data Center Director and distinguished research and data staff in the Environmental Science Division in Oak Ridge National Laboratory. So thank you so much, Gir, to join us. This is a very nice opportunity to see you again and to join the Brazilian community. Most of Brazilian community do have others researchers, not just from Brazil, but most of them are Brazilian. Thank you again. You have done a very great job with us in Brazil. Thank you so much, Gir, and please feel free to follow with your presentation. If at the end we have some opportunity to make some questions to Gir Prakash, please just put your question in the questions bullet that we have available in the meeting. Okay. Thank you so much, Gir. Please go ahead. Thank you.
Thank you. Pedro, can you hear me okay?
Very well, very well.
Well, good afternoon. Thank you. Thank you so much for Professor Pedro here for inviting me to give this talk. And let me share my screen, see if this works. So I'm not very familiar with the Google Meet. Is that start streaming is the one that I need to?
Yeah, you can share your screen, or you can choose. You can choose just a tab or of
Share your screen. Yes.
or their screen. Maybe their screen is better. Entire
Okay.
screen is better. Thank you, Gir.
Yeah. It's okay, and it's probably going to take me a couple of minutes here, I guess.
Don't worry, don't worry.
Yeah, it's not letting me share my screen for some reason. Let me see. So Pedro, I may have to send you my slide.
Yes, you can send me here.
Yeah, it is letting me share it.
Don't worry. No problem.
Okay. Should I send it to your email or?
Yes, please.
Okay. Sending you right now.
Mm-hmm.
Okay, I just sent it to you.
Okay.
See if that works.
Maybe 1 minute. Just waiting. Not yet. I know that Google has some security threads. I don't know. Maybe you've
Yeah, that's what I was trying to get that one
Google
fixed.
meeting. Sorry.
Okay. Let me quit and reopen. Give me 1 second.
Okay.
I am back and hopefully it works this time. Let me see. How about now?
Awesome.
You can see my screen?
Yes. Yes. Perfect. We are in
Okay.
presentation mode now. It's perfect.
Okay. Thank you so much, Pedro. Thank you all. Sorry about the delay. I had to restart my permissions here to get the screen sharing going. And good afternoon. I would like to spend a few minutes talk about the atmospheric radiation measurement data and metadata management. And you heard a very wonderful talk from Muhammad on the data side, how they are helping programs like ours to really create the DOIs and the citation metadata that is needed to create the PID and DOIs. So we are a big fan of DataCite, and you will see how we are utilizing DOIs from DataCite in my talk. And so Professor Pedro requested me to talk about how we manage sensor data and data from various instruments. And I will give you a lot of detail on that and also some background. Okay, let's jump in. Okay, so what is ARM? ARM is an atmospheric radiation measurement facility, and it's a long-term facility, and we have been operating since 1992, and we have over 500 instruments. And the map that you see on the right side, we have the blue dots means we that's our long-term observatories, one in Oklahoma, USA, and the other one in Alaska, US. And then there's another one called Azores, which is a small Portuguese island. um, and then we have what we call three mobile facilities where we essentially pack a lot of instruments and then go to different places to study a specific atmospheric phenomena or event that we want to study. So we were, just to give you an idea, we were in Manaus and Manakaparu back in 2015. We wanted to study the aerosol impact from Manaus, from the city, and that goes into the Amazon area, and how the biological parameters getting impacted. So we were there, and similarly we have been to all these different places. We've been to Alaska, to Antarctica, and anywhere in between. So just to give you a quick information about ARM. We, as of yesterday, we have a little over 8 petabyte of data that we archive and distribute to all the users around the world. This is just to give you an idea. In 2025 so far, we have users from 38 countries and collecting or using our data for their research. And here is a small metrics on the publications. We have over 200 journal articles that was fully utilizing the ARM data. And then we have other abstracts and technical reports and so on. Okay, so ARM is the world's foremost ground-based atmospheric observing facility. So we have over 470 instruments, and then we also have aerial, very robust aerial measurement program, and also we have a robust computing infrastructure, high performance computing infrastructure that actually helps our users to do large scale model observational intercomparison activities. And for the data services, as I mentioned, like we have so many instruments, and just to give you an idea, we get about 10 to 12 terabytes of data from all these instruments every day, and we had to go through quite a few processing. As you can imagine, like we can't do that all manually, so we had to really automate everything, and from collecting, transmitting the data, securely transferring to the ARM data center here to Oak Ridge National Lab, and then processing, doing the ingest and analyzing the data quality, and then also feeding into a value-added product. So all these needs a really robust integrated data and computing system, and that's what I work on, and we have quite a few computing resource and data resources that actually helps us process these like thousands of data streams every day. Okay, so here is a top level diagram that actually shows you how the data flow, that the top side where you see the blue boxes, those are all of our observatories, or the sites where we collect data. And then what we have is a site data system. Those are deployed right in each one of those facilities, and then which connects to the instruments, and that transmit the data securely from instrument to the sites to the ARM data center here at Oak Ridge National Lab. Once the data comes in, it goes through various processing like data ingest, reprocessing, and science product development, and then semi-automated metadata creation, archival, and then finally we make it to the users. So even though it involves multiple steps, almost all of our continuous data streams are right after we collect, it goes through all these processes, and then will be available to users within 24 hours after we receive the data from the instruments. So that's how fast the data can be accessed by the users. In addition to that, we have quite a few field campaigns that our scientists or anybody in the world can propose a field campaign and make use of our sites, bring their own instrument, and then collect data. So those teams also provide data. We call that as PI contributed data or research data that goes into our archive, and then we also make those data available to the users around the world. So for all these things, like we really need to make sure like we have a very comprehensive data processing capability, and we have really good set of softwares that manages the data flow and assess the data quality, and then make the data available to users almost immediately. For very few cases where we essentially provide our data near real time, and for that we have a separate workflow, and then also we have to monitor all these processes, all these instruments, whether it is operating correctly and producing and transmitting the data, and then our processes are fully completing the end-to-end data flow and make it to the users. Okay, so metadata, Professor Pedro asked me to talk about how we manage the metadata. And metadata is such an important thing. It basically describes your data. And without a comprehensive metadata, it is very difficult to make use of our data. So that includes instrument categories, instrument classes, codes, and spatial and temporal information, and data quality variables, and in many cases, like our archive or repository contains over 18,000 data streams, and we need to make sure like we provide some kind of data recommendation similar to some of your shopping websites, but in this case recommendations based on data quality, completeness, and other factors. And then we also have very good detail in our metadata about like who is managing this instrument, and if the user has any questions about how we collect the data using that specific instruments. So all these contacts, descriptions, and instrument handbooks, all of them are linked through the metadata. Okay, and as I said, like we have over 18,000 data products from 450 instruments, and so we always look for unique way to highlight the high quality data through our data discovery on our website and our data workbench and other things which I'll be talking about in the next few slides. But we also continue to improve the user experience. One of the recent thing that we did is providing a data epoch or a set of data that falls into a specific data epoch, meaning like if there is an event that happened, like be it a hurricane or be it a volcano eruption or anything like that time, if we observe our data and if we see any anomalies, we flag them as a data epoch, and then make it available to the users. Okay, so to give you an idea, the instrument metadata is a very comprehensive one, and you are welcome to go to the arm.gov, arm.gov, and then you can search for data discovery under the data tab, and you will be able to see the entire comprehensive data that we have collected so far. And so various ways to discover these instrument metadata using their interface. You can do a keyword search, or you can pick the location and then drill down, or the guided search. Basically, like if you're familiar with method, measurement, or instrument, you basically answer a few questions, then it will take you to the results. And here is the results page. It shows you all the different facets or the categories and the classification. And this is just to give you an idea. All of this information coming from our metadata repository, and you can actually see the detailed information about that specific data stream or data set. and that includes location, time period, and data type, and including the DOIs, and then access to the plots. And then on the right side, you also see the timeline that actually shows how long we have been collecting the data. You can quickly zoom into one of that specific area and then click. Let's say, like if I click the yellow or gray color, it will show you the data quality information right away. And this allows users to pick whether that data can conform their quality needs or for their specific needs or not. And then you can also see a lot of other oops, uh, lot of other details in that page, including the variables that we are collecting, and also the contacts and additional information and so on, and then links to visualize the data and add it to the cart. Okay. So here is one quick example on the data quality report. When I click, it actually shows on the details. In this case, yeah, so why there is a problem with the data quality, and then like what are the affected measurements and so on. And then the user can select the data stream of their interest, and then they can pick the variables that they want, and then make it available. When we will make it right away available, once they make an order, we fetch it, we extract the data, and then make it available in a FTP area or Threads or OpenDAP or the Globus for larger data transfer. And then we more recently we actually enabled accessing our data using the Jupyter Notebook capability. So you can go there, order the data, and then ask this to be placed in a Jupyter Notebook, and then the data will be placed in a Jupyter Notebook, and we will be sending you a link along with the sample Jupyter Notebook, so you don't have to start coding from scratch. So you can right away get into analyzing the data. Okay, and okay, so as I mentioned before, we have a very robust computing capability that allows both for our operations as well as our users to make use of our high performance computing to do some long term or complex data analysis. And so it allows basically to run a huge model or daily data processing and so on. So we have a HPC high performance computing cluster called Cumulus, which has around 17,000 computing cores. And so the data, so one of the more recent one that we developed and provided users is the data workbench. And it actually allows users to really utilize all three major resources that ARM has, which is like 30 plus years of data, and then a robust computing infrastructure, and also the software that we have been developing and giving it to the community through open source means. Some of you probably like experienced or experimented our software called PyArt and ARM Community Toolkit. So in this data workbench, basically we bring in all three of these resources and provide it to the users, very very seamless access to the users, and users can access all of these data within the data workbench. Yeah. And the link that I have here, you're welcome to go check it out. And then if you don't have an account, it is free to create an account with ARM. You just need to fill out a registration form, and right after that, you'll be able to utilize our data. And here is some screenshots, and then the left side is the screenshot of our data workbench, and then the right side shows our new tool that we developed called Data Studio, and which really allows users to visualize our data without coding, and by utilizing our computing resources as well as our open source software. So I want to say, like, many of these, like including the data discovery and the workbench and the Jupyter notebook, we have been having a very productive and long-term collaboration with Professor Pedro and University of São Paulo, and many of these we actually had interns coming from Professor Pedro's lab and helping us develop this. So some of this Jupyter notebook work that you will see when you go to ARM, actually it was produced and developed by the students from Professor Pedro's lab. Okay, Pedro, do you hear any background noise from me?
Yes, I can hear. I don't know if someone, we can check if someone is with open.
Oh, yeah, hold on one second.
We will check. We will check.
Yeah, it could be me. Yeah. Um, yeah, my kids are here at home for the Thanksgiving.
Thanksgiving.
Yeah, and just give me 1 second. Let me just request them to.
But the music is nice here. There we can listen you very well. Don't worry.
Sorry about that. I'm back. Okay. All right. Yeah. So in addition to the data archival and all, so we also added something new, and which is called field campaign notebook, and it really allows our scientists and field technicians to really use this notebook to help with the site operation or instrument operations, and also if they want to run an experiment, they use this to pick the real-time information from multiple sources, and that includes data from ARM, and also real-time NASA data streams, and weather details, as well as Nextrad and few other satellite data products. And so this really allows our PIs and site operational team to conduct the experiment the way by utilizing the real-time information. Okay, so we're all into the AI now, and so at ARM we have been working on enabling AI not to provide the data in AI-ready format, not only, but also actually improve the operational efficiency by, for example, like we have edge computing that does the data reduction at the source, and then we have AI in the works to improve the data quality analysis, and also AI for data recommendations, which we are almost ready to put it out. Hopefully, it will be ready in couple of weeks, or probably like a month, where users will be able to go and ask question, and then our data recommender would actually provide them guidance on what data that they want, and then it will fetch the data that they want and put it in a format that they want. So very exciting work happening using the AI to improve the overall operational efficiency, as well as user experience. Oops. All right, and So I'll give you a couple of examples on like how we are using the AI for our data recommendations. As I mentioned, like we have tens of thousands of data streams, and users will be overwhelmed when they search for data. So what we are trying to do is actually using multiple sources. Like what we have the history of the data access from the users, and also we have all the metadata about the data, and then the user also provides ORC-ID, and we utilize all of this, and then and really understand their research needs, and then what we have, and then based on that we actually provide good recommendation using AI. And this is currently available. Oops. Um, and and it is available through the data discovery, and you can, once you log in, once you create an account with ARM, and once you log in, and within the my account dashboard you can opt in for AI based data recommendation, and then it will take a day to run, and it has to fetch your ORC-ID, publication list, and other things, and then the next day onwards you'd be able to see the data recommendation specifically tailored for you. This is something that we put very recently, and we have been having a good feedback from the user community. And here is a diagram that or the figure that shows how to read our data, because we do have quite a few data. We organize in this format. Basically, I'll starts with the site and the instrument, and then data level and the date, and so on. Okay, so lastly, I want to talk about the data citation. And as Mohammed did his talk before, we heavily utilize data sites, DOI strategy, and the resources. And we have actually we have been creating DOI since 2012, and I'm happy to say that people started utilizing the DOI that we are providing, and we can see the adoption of DOI has been increased tremendously, and we are also keep updating and revising the DOI strategy or the citation strategy, especially for continuous data streams that we have been collecting. So if you have an instrument that collects data all the time, in addition to have a DOI for that instrument or the data that comes from that instrument, you also need to have a good citation strategy that allows users to use the DOI along with temporal and spatial scale to ensure the data reproducibility. And oftentimes we use multiple data from multiple sources, and we wanted to make sure like all the data sources gets credit too. So I was so glad to hear from DataCite when they provided a hierarchical versioning strategy, and also a hierarchical DOI strategy. So we are able to utilize those also, and a really good experience so far. And many people asked me over the years, how do you create a DOI? How do you do a data citation for continuous data streams? And I ended up writing a paper a while ago, and I listed it here. You're welcome to take a look where we go through the data citation strategy at detail. And that is all. And finally, I wanted to thank Professor Pedro for inviting me to give this keynote. And thank you, Pedro. We typically do it in-person meeting, and unfortunately, the time did not work out for us. So we don't want to pause this year, and I'm so glad the work. This is this tradition started many years ago, and Professor Pedro has been extremely successful in bringing all of you and the wonderful speakers to do this very important thing for the scientific data community. Thank you, Pedro.
Thank you, Gear. It's important to say that this is the 10th, the first workshop that we started in 2015. It was the first workshop in data science in all University of São Paulo. Was the first workshop that you inspired us. Thank you so much, Gear. This is because you start this workshop and you start all this research area. Thank you so much at university, at Escola Politécnica, work with big data. Thank you so much, Gear.
You're welcome. Thank you, Pedro. Thank you.
And
I'll take any questions. Yeah.
Yeah, and Gear, we have some questions. I have one question. I think there are many other questions. The people that they make some questions in the chat here. Tony will read for us. But I have one question. I love your presentation.
Thank you.
Yes, it's nice because I just now I am update about the all advances of ARM. I think ARM is in the considering in as a data repository the most advanced in the world, considering all features that you have. I don't. This is incredible, and you learn a lot with ARM. So continue. Just I read about the data flow that you connect with sensors in different sites. So, for example, I read that in 2 hours, when you collect the data in 2 hours, you have available in data portal. Could you talk a little bit about this data flow? How flow this from the sensor that in the field,
yeah,
through the data portal? Just talk a
yeah.
little bit about this.
So yeah, we so when we deploy the instruments in various places, right? So we actually first thing we need to do is like deploy a computing resource right there along with the instrument so that it will receive the data, and then we with a proper networking strategy we are able to send the data right to the Oak Ridge National Labs ARM Data Center, where we go through the processing and then make it available to the users. And some of this data, as I mentioned, we do it almost near real time. And in those cases, like the data will be available through our API within a couple of hours. But like many of those, we continue collect the data at our sites, and then we ship the data essentially every 15 minutes or so to Oak Ridge, and then we continue to add the data as the day progresses. But then right after midnight, our compilation will be done for the previous day, and then the next process happens, and then in the morning, people will be able to get the data. So from the full previous day worth of data. And many times, like we have good networks, and sometimes we have to use satellite networks. We use Starlink, we use 5G wherever it is available, and to make sure like the data is flowing really fast.
Yeah, it's incredible, and this is what you have to do in the Amazon phase. This is because you are collecting some instrument that are ingesting carbon, and you are just send all information about the level of carbon in the data portal. So you are transfer this data, and you have, of course, you have a delay because you must check the data quality, you must check everything. But
Right.
I think all of this process in ARM is part of this process. You automated, then there is no person involved with this, or just automated every phase of this?
Yeah, it is semi-automated, Pedro, meaning like when we get the data very first time, and our experts need to look at it and then look at the data quality and other things. But once we are done at the initial stage, the data continues to flow, and our algorithms actually try to figure out the data quality. And if there is an issue, it creates a data quality report and so on. So the data quality standards that we follow, many communities started making use of our strategy and our resources, and it is available to anybody how we do the data quality. And yeah, so phase and other programs can take a look and make use of it if they want it. And of course, like, there will be a one-time investment, Pedro, as you know more than more than me. You will have to develop these workflows. Once you develop these workflows, then you can scale it for other programs or other experiments and so on. So yeah, similarly for the metadata tool that we have been using for PIs to submit their data. So there is a one-time investment in tool development, but once you have that, and then it works smoothly.
Awesome. Thank you. Here, there is another question. Please, Tony, could you read this question?
Yeah, sure. Actually, I just want to say that it's an absolute pleasure to see you again, Giri. I loved your talk, and I learned a lot as always. And I will copy and paste some futures again. Okay.
Yes, thank you, thank you. Good to hear from you. Yeah.
You really rock it. Actually, we don't have any oh, actually we do. Sorry, I would. Sorry, Marshall has a question. It's just come out. As the volume of sensor data explodes, is the manual expert reviewing becoming a bottleneck? Or that's the first question. Are you exploring LLMs to automate the metadata review?
Yes, absolutely. So we already have like so many data streams coming in, but we are not doing manual review every day. It is like when we deploy an instrument very first time, and when we get the data very first time, that's when our experts actually look at it and then really define the data quality parameters, and that goes into our algorithm. And then from that day onwards, it'll be like mostly automated. And if there are some major anomalies that our automated script finds it, and then it actually sends to human verification. But other than that, like, it continues to run. And with the metadata, the second question that you asked for LLM, absolutely, we are utilizing the LLM. I think I went very fast. One example is really automate the creation of hierarchical metadata using LLM. And so we have already implemented that, and it is actually helping our metadata team to generate automated keywords and the categories and other higher level metadata. But we are also working currently essentially provide what we want to do is, like, in our metadata entry tool that our PIs and teams and scientists use, we want to cut down their time when they try to submit their data. So for that, we are currently developing a strategy where we bring in multiple ontologies and multiple AI models. Essentially, when they log in, it pulls the details from OrcID publication, and then like figures out and also reads the data that they are submitting, and then essentially pre-fill everything that we want from the PI, and then the PI get to review it and then submit it. So we are utilizing or will be utilizing LLMs in multiple places.
Awesome. LLM, it's a very important to use, because I think for the scientists publish your data, they spend so much time, so much effort. So you can reduce this time, reduce this effort for the scientists would be nice. Awesome.
Yeah,
Yeah. Yeah.
absolutely. Yeah,
Yeah.
yeah. We have been developing very actively developing agentic AIs
Mhm.
that would really take multiple resources and then essentially feed into the LLM. Yeah.
Awesome. Is there other questions for audience?
Actually, no. Let me see. No, we don't. But I have one. Like
Sure.
it's a weird one. What do you see as the main challenge for ARM's data and metadata measurements in the next few years? Like in your perspectives, like a specialist and director.
Yeah. Um, Multiple challenges. One is data growth. So just the data growth itself, we have to continue upgrade, continue bring in new resources, hardware resources. So that's always a continuous challenge. And also the technologies that is evolving in a really rapid phase, we need to keep up with that, and that's another challenge. In terms of data, we have quite a few. I mean, like as I said, like more than 8 petabyte of data, and um, um, some of these models, AI models, they want to use almost all the data that we have, and then enabling all those 8 petabyte data for a model is a challenge, multiple challenges. But at the same time, we are trying to do what we can, smart way to provide the data that they need, not just simple data, but also like giving them metrics or statistics and things like that. So that's also continue to evolve. Um, what are the challenges? Um, Again, the major challenge would be like soon we want to move from file based data access to more like a data that will be ready to ingest in your analysis, whatever that format is. And then sometimes like you may want to like ask a question to ARM, and the ARM will give you the answer by crunching through the data, of course using HPC and so on. And so that's, I mean, people want to know the result right away. What do you have? Like, how is this impacting something? So all those conditional querying that they want to ask our portal, and they want the result back before even they want to download the data. So those things, like, we need to keep up with that.
Perfect. Thank you so much.
Sure.
It's important to say that here in Brazil, you are very focused on the metadata capture because we don't want to lose data. It's
Oh,
important to capture all metadata with quality, and this is it's very important. I think would be nice if you could make some collaboration related with metadata tools, and how you can automate it or make part of this process here in Brazil, just to make sure that we are collecting all metadata and necessary to the data that you are collecting in Amazon, because this data will be for 30, 40 years. I don't know how long. So it's important to have all metadata collected, and the quality we must take care about this. This is what you are considering in this phase in your project. And
well, that's step
yeah,
number 0, Pedro. That's the very first step. Yeah,
yeah,
that
and yeah. This is very, very, very important, and this kind of collaboration would be very important with ARM. I
yeah.
think we can go forward in this direction. Would be very nice.
Yes, yes. No, I'd be happy to talk about the open source tools that we are using for metadata generation, also metadata data quality verification, and so on. Yeah, yeah. Pedro. Yeah, anytime. Yeah.
Yeah. Is there other questions?
Yeah, there is. It is an anonymous one. It's a secret one. I don't know who, but the question is, where can we find automatic scripts or tools to check the data quality of Lycor instruments? I've been searching for resources, but I haven't found any useful tools to help me perform quality checks on these data sets.
For which data sets did you say, Tony?
Lycor.
Like,
Lycor instruments. I don't know. Even I just reading. It's Licor instruments.
What's
I
like?
don't know what it is.
okay.
Maybe it's something specific one. I think Marcio Teixeira in the other presentation asked something about it. I
Oh,
think it's Amazon Face something instruments. I don't know.
okay. Well, if they can reach out to me, I don't think we have Lycor data. I hope it's not a spelling mistake. If they are talking about LiDAR data, uh,
LiDAR.
yeah,
Yeah.
LiDAR. Yes, we do have our data quality. I guess like a strategy, and then I can actually send them the instrument handbook. Basically, it talks about
Here,
data.
hey, here, excuse me. Here is Marcio. How are you doing?
Good, thank you.
I'm using Rosa's account because I am not allowed to open my microphone. What I meant on that question is the following. In Amazon Face, we have a diverse amount of data. So I will basically rephrase it here. It's we have social data. We have people that measure conductivity on leaves. We have people that measure the flow of I don't know what's the name of saver in English. Set flows, and all those things. And for example, and this instrument in particular is a Lycor. It's used to measure methane or CO2, this kind of
Oh,
thing. So
okay.
it's very, very diverse data, and it's soil based. So the question is, as you are also you guys there are experienced with this very diverse data collection, do you have any advice for us on best practice, how to store, integrate this? Because this will be a big challenge. As I mentioned to you, we will have they will interview people from the community and ask, for example, if their food supply have been altered or if they feel any difference in the environment. So do you have, it's very different for me. I'm used to atmospheric data, meteorological data. So any advice on that, on how we could, any best practice to treat all this diverse data in time scale and formats, etc. Thank
Yeah,
you.
yeah. Well, that's thank you so much for jumping in and explaining us. Yeah, so at ARM, we specifically focus on atmospheric parameters, right? But what you're saying is like you collect data from surface, subsurface, and also atmospheric, and then social data, and that's it is a complex problem. There is no magic button to push, right? So, what my advice to you is really pick up some standards. So there is an ISO 19115 metadata standard, and there are some extensions for different type of data. So if you look at it, like they say for this social data, these are all the minimum variables or minimum metadata that you need to capture. And similarly for other data, they guide you what are the things. I mean, like essentially you have the basic metadata that could be applied for almost every type of data. One is like where, when, right? So where is the location information, when is the time period, so those are, and then what. So those three are like always like, yeah, it doesn't matter what type of data, so you basically able to describe it. And then you go into keywords and domain specific keywords, and then hierarchical keywords, and then data quality, if there are any anomalies, like let's say like how conform that the data source is, those things. That's where like picking a right metadata standard like ISO 19115, it actually gives you all the different options, which one you want to use it, and then how you want to use it. And Rosa, if you can please connect me, I can send some additional details via email.
Awesome. Is there other question? Any people in the lab? There are. We have one connection of Rosa. If some people in the lab, yes. Is there any other question? Awesome.
There are another question. Thank you very much, Gary.
Thank you, Rosa. Good to hear from you.
Okay. Gear, I think there are other questions. I have other questions, but I will be so deeply in the some specific subject, maybe will be not interesting for everyone. But it's important to highlight that your presentation gave us a general view of all major features that the very nice repository data, that scientific data should be managed. So it would be very important to listen and understand the experience or all experience of ARM and bring all of best practices or good solutions, and we focus on our priority right now here in Amazon Face. I think we're going to in this direction, but ARM has like a menu and you just pick something and some ideas and
anytime. Yeah, if you and the team wants to talk to me, I guess explore the capabilities that we have, I'd be happy to dial in.
Yes, awesome here. And I think you have all team of Amazon Face here, and the data management team will listen. You are listening right now, the Uger. So thank you so much. It's a very nice opportunity to understand it, to give lessons for us. Thank you so much.
You're welcome, and have a great rest of the workshop. Yeah.
Awesome. So, Gear, we are going to finish our section right now.
Okay.
And tomorrow we are going to continue with hands-on. We have a hands-on related with curation, data curation. You are doing data curation. We are trying to make what tools you are going to use to make available, to publish the data set available in the Amazon Face.
Okay.
You are publishing data map. So tomorrow you are going to discuss in this. But today we are very happy with this first day of the workshop, and they will have a very, very nice presentations. Finish with gold presentation of Gear. Thank you so much, Gear.
Thank you, Pedro, and thank you all, and happy Thanksgiving to everyone.
Yeah, if possible, we can share the I don't know, you can create some slides, or you are share the presentation.
I will share you. I mean, you have my slide,
Yes.
and
we can
create it as a PDF and then share it.
You put DOI and Zinode or some place. Oh, look at it! Look at people there.
Hey, Hosha. Hey, good to see you. Yeah, good to see the team.
Oh, great!
Gente aperta. Aperta. Tira o print, Rosa.
Print. Esperemos que ele não pare.
Hello, good to see you all.
Thank you, guys. Thank you so much.
Thank you.
Nice picture. Thank you everyone. Thank you for all attendees of the workshop. I think we have a very nice questions. I think we will have good moments and understand better about the data science ecosystem. So thank you so much. Thank you all keynotes and thank you all attendees. Thank you.
See you.